The last thing we're going to do in this chapter is actually take all the information that we've been able to find about these quadratics, and we're going to actually graph them. So I'm going to start with graphing the function y equals x cubed minus 3x squared. What's going to start with is 0. Plug in 0 for x. If I do, I get 0 for y. And then move in the positive direction. 1, if I plug in 1 cubed minus 3 times 1 squared is negative 2. If I plug in 2, I get negative 4. If I plug in 3, I get 0. And if I plug in 4, I get I get positive 16. And that point right there is off the graph. So we know that's where it takes off, and that's where it's not coming back down. Then pick up from 0 and move in the left-hand direction. So if I plugged in negative 1, I'd get negative 4. If I plugged in negative 2, I'd get negative 20, and that's a clue that it's off the chart. We've moved outside of the area of the graph. It's probably not coming back down, and those are the points that we can now say that we've graphed. And you can see I've graphed those in red. The other clues that we have for this drawing is that the leading coefficient is positive. This is a positive x cubed. And since it's a positive x cubed, I know for a fact that the right end is going to be going up. It's going toward positive infinity. And since the degree is odd, it's a 3, since the degree is odd, we know that the left end acts in the opposite direction, so the left end will be heading in the negative direction. And so I got this part of the clue and this part of the clue. And the degree is 3, so we know there's going to be two maxes and two maxes or mins. And so at that point we can then try and make a sketch of this graph, and we know it has to have two maxes or mins, and the right end's going up and the left end's going down. So here I start, and I can just sketch the graph here in green, and that's probably something very close to what it looks like. And that's all we're shooting for today. Next example. The function 2x cubed plus x minus 3x. Again, let's make a table of x's and y's. Start with 0. If I plug in 0, I get 0. If I plug in 1, I get 0. If I plug in 2, I get 14, and that's my clue that I've moved outside of the main area of the graph, and it's probably not coming back down. So then try some negatives. Negative 1, if I plug that into the expression here, I'll get 2. If I plug in negative 2, I get negative 6. And if I plug in negative 3, I get negative 39. And that's my clue that I've headed out past where the predominant part of the graph would be. The other clues that I have for graphing this are, since the leading coefficient is positive, I know that the right end goes up. The degree is odd, so the left end goes down. And the degree is 3, so that there will be two maxes or mins. And armed with these 6 points, and some information about where it starts and ends, and how it acts in the middle, we can make a sketch of the graph, and it looks probably something like this.